In computing, our main aim is to ensure that all of our students, by the time they leave the Griffin School, are equipped with the essential IT and programming skills that they will need to meet the challenges of the modern world. We want to enable our students to become digitally literate members of society who are able to fully take part in and shape the ongoing digital revolution. Throughout their time at the Griffin, we hope that students will develop a genuine interest and appreciation of computing as a subject. They will develop an understanding of how computers work and also the core IT skills to ensure that they become digitally literate. Students will also get to experience a wide variety of multimedia software, as well as learning to program in at least 2 different programming languages. Students will also be supported with use of the school intranet and other IT resources, and students will be taught the risks of staying safe online and how technology can impact the environment. In computing, we have 2 main pathways. One is the creative iMedia pathway, the other is the computer science pathway. iMedia is much more focused around creating multimedia products, whereas computer science is more focused around computer hardware, software and programming. Here you can see that in Key Stage 3 we teach students a mixture of computer science and iMedia. Computer science in yellow and iMedia in blue. This is so students are well equipped and have experience of both subjects, so that when they reach year 10 and have to choose an option, they have the necessary skills to move forward with either computer science or iMedia. Students can then choose to continue this at Key Stage 5 by studying A-level computer science or the BTEC in creative digital media. In year 7, we start the course by ensuring that students have solid knowledge of basic IT skills such as how to use a mouse, keyboard, and how to manage files and folders. We also teach students the basics of e-safety, such as how to stay safe online and how to discriminate different types of information. I'm now going to focus on just the creative digital media strand of the curriculum, and I'll explain how students progress through Key Stage 4 and 5 following this strand. In Year 7, students will produce simple websites of a single page, including text and images on a topic of their choice. As you can see here, the example this student has chosen to do is a simple page on climate change. In Year 8, students continue to study website design. This time they produce multi-page websites with links, hyperlinks such as the navigation bar you can see on the left hand side of these pages that link to other pages. Students also design a banner for their website in Photoshop, such as the one you can see here for the Van Gogh website. In Year 9, students learn how to create multimedia presentations, such as the one you can see here on a music festival. Students use buttons in their presentations to link to multiple slides. Students also create a video and a poster and other types of multimedia to go into the presentation. The presentation is fully interactive and can be viewed by clicking the different buttons. Also in Year 9, students learn how to use Photoshop. Students will learn how to use all of the tools of Photoshop, such as the brush tool, which is used to create this image of the planets, and other advanced tools like the clone stamp tool, which has been used to copy the windsurfers and create lots of duplicate windsurfers in the image, or to remove items from an image. Students are also taught how to use layers to combine different images together. Here you can see the overall progression for the digital media strand, showing that in Year 7 students understand how to create a basic website and repurpose digital assets such as images, and how to create simple word process documents. Extending this in Year 8 by creating multi-page websites including hyperlinks to other pages and repurpose assets for a particular audience, and using advanced publishing software. In Year 9, students are then introduced to multimedia products, interactive multimedia products, and learn how to manipulate images on an advanced level in Photoshop. In Key Stage 4, students can continue the digital media strand by studying creative iMedia. This includes creating multimedia products, digital graphics using Photoshop, and websites. Here is an example of an interactive product students have created for digital iMedia. As you can see, it's similar to the products they create in Year 9, but at a more advanced level with many more pages and with a particular focus on style and presentation and colour scheme. Here's another example of images created on the iMedia course for the unit on Photoshop. These are posters for a photography competition, and students have had to use several advanced skills such as multiple layers, changing image opacity, removing backgrounds from images, and other advanced skills. At Key Stage 5, students can continue to follow the digital media strand by choosing the BTEC Creative Digital Media. This continues with themes throughout the year, such as image manipulation with Photoshop and website production, and also includes a unit on magazine production and photography. Here's some examples of student work from the magazine production unit. Students use InDesign to create front covers of a magazine and a double page spread. They also use Photoshop to edit images and photography skills to take images of models for their magazines. Here's some examples of film posters that students have produced in Year 13. Students have used many advanced skills, such as using their photography skills to take images for the posters and also removing backgrounds, advanced skills with paintbrush, dodge and burn, and other image manipulation tools. We will now look at the computing curriculum across Key Stage 3, 4 and 5 in more detail. In Key Stage 3, students all learn how to do basic programming using a programming language called Scratch. They create their own computer game characters, which they draw themselves, and then they add code to make the characters move around the screen and animate the characters. Students also study a high-level programming language called Python in Year 7, and they learn to create a basic chatbot program which acts as an artificial intelligence that students can interact with and ask questions. In Year 8, students extend their programming knowledge by continuing with Scratch, but at a more advanced level. This time students create a Scratch game with artificial intelligence where the students control a helicopter and have to avoid various obstacles and enemy characters who are trying to attack the helicopter. This uses more advanced programming skills such as data structures, variables, selection and iteration. Students also continue to study Python programming in Year 8, this time with more advanced programming skills such as loops, while loops, if statements, and they also learn how to use libraries such as the random library as shown at the top of the code. This is a program to generate a random number with the user having to guess the number and the program feeding back as to whether they are too high or too low. In Year 9, students learn in much more detail about computer systems. This includes how to convert binary numbers to denary numbers and vice versa, how the CPU works and the different parts of the CPU such as the registers and the fetch, decode, execute cycle. This shows the overall progression at Key Stage 3 for computer science, As you can see, at Year 7, students use 2 programming languages, one of which is a text-based language, which is Python, and students will understand different hardware and software components that make up a computer system. In Year 8, students continue to extend their programming knowledge by continuing to use Scratch and Python, but of a much more advanced level using different data structures, procedures and functions. Students also learn in more detail about the hardware and software components. In Year 9, students learn about binary numbers and how to convert binary and decimal, and learn in much more detail about how instructions are stored on a computer. At Key Stage 4, students can continue the computer science curriculum strand by choosing to take Gcse Computing. Gcse Computer Science goes into more detail about algorithms and programming. Students learn how to follow complex algorithms and also program their own computer programs, such as this dice game. They will also learn how to test their programs and create a test plan to ensure that their programs are robust and do not contain any errors. Here is another example of an advanced computer program that has been created for a GCSE Computer Science project, which is a dice game that keeps track of 2 dice rolled by 2 different players, and players play against each other, scoring points by rolling the higher dice score. If students continue to study computer science at Key Stage 5, they will be completing the A-level in computer science. The topics studied at A-level are very similar to the topics studied at GCSE, but obviously at a much more advanced level. Students will be working with more complex algorithms and developing computer programs with a much broader scope and complexity. Students also complete a programming project in Year 13 on a topic of their choice, which is a very large project worth 20% of the overall A-level. An example of a computer science project that a student created is a point-of-sale system for the school canteen. So this system uses a webcam to recognise, first of all, the user's face using facial recognition, and also can scan barcodes of products to take money off of the balance when somebody buys a product. So this required use of several different libraries, integration of the webcam, facial recognition software, and creating a user interface. Another example of a A-level computer science project is a digital version of the popular card game Uno, which shows the player playing against an artificial intelligence that was coded by the student. So this project has all the features of the regular Uno game, but is a digital version. Finally, during their learning journey at the Griffin School, all students will get to experience a huge range of software, including the entire Microsoft Office suite of products, including Word, Excel, PowerPoint, Access Publisher, various animation software such as Pivot Animator and Adobe Flash, Photoshop, Adobe Illustrator and Dreamweaver, and various programming languages such as Python, Scratch and Notepad++. Throughout their time at the Griffin, students have the opportunity to undertake a variety of creative products that involve selecting, using and combining multiple applications.